Hello and welcome again to my channel. Today we are going to solve question number 659 of Leetcode and it is marked medium. What what this question wants us to do? Let's understand it. So we are given an integer array. Okay. In the question it is given that the array is in a non-decreasing order, right? You see there's 3 and 3, right? It cannot be 3 like 4 and 3, so it will be non-decreasing. It will be at most exactly same, but it will not decrease as we move further, right? And what do we have to do? We simply have to break them into parts, subsequences, right? We have to split them. And how do we split them? We split them by what was it, into one or more subsequences such that both of the following conditions are true. Each subsequence is consecutive increasing sequence, right? Consecutive increasing sequence means if you split this in a subsequence, the 3 and 3 cannot be part of a single subsequence, right? Like a subsequence cannot be 1 2 3 3. Why? Because 3 and 3 are not consecutively increasing. It can be 1 2 3 4, right? So that's the first condition. And the second condition is all subsequences have a length of 3 or more. So basically we cannot also do 1 comma 2, right? It is increasing, 1 and 2 is consecutively increasing, but it is not of length 3. Every subsequence have to be of length 3 or more. So these are the two conditions that we need to follow. Okay, let's first see what the answer for this input is. The answer would be 1 2 3 4 and 5 in one subsequence, and then 3 4 and 5 in another subsequence. So basically I'll just write it down. In one subsequence it will be 1 2 3 4 and 5, and another subsequence will be 3 4 and 3 4 and 5, right? Now if you see, we have used up all the numbers from the array, right? That is also the meaning of splitting, right? We cannot leave any numbers behind, right? We cannot do 1 2 3 and 4 5 6, sorry, 3 1 2 3 3 4 5, right? Then 4 and 5 would be in the array, right? We cannot do that. So we have to use all the numbers and split them into subsequences. Each subsequence must follow two rules, which is consecutively increasing numbers, and it has to be of length 3 or more. Now let's discuss how we will solve this question. Let's imagine I'm standing here in this index with a value of 4, right? Imagine you are standing at that particular index. You don't know anything else. You're just standing in that particular index, seeing the value 4. What thought would come to your mind? Like, what would you think? How would you solve that for that particular number? What do you think is, you have to know two things, right? Whether this particular number would be added to any of the pre-existing subsequences we have, right? It will be a part of an, it will continue extending an subsequence, or if that's not possible, will a new subsequence start from this number itself, like it will be the first number of a new subsequence. Is that possible, right? If these two cases are not possible, then we'll return false. Why? Because we cannot form a subsequence using this number. If this number cannot be a part of an existing subsequence, and this number cannot produce a new subsequence itself, like starting with itself, this number cannot be used. And it is one of the conditions, like every number has to be used, right? And if it's not possible, we'll just return false. So that's the breaking condition we have found, right? Now um as I said, we need to check, just write it down. We need to check if the current number is a part of a pre-existing subsequence, or number 2, will a new subsequence start from this number itself, right? We have to check these two conditions. Let's first determine how we'll check the second condition first, right? So imagine we are starting a new subsequence, right? We cannot simply say that, let's say initially the subsequence is empty. We cannot directly say that we'll include the 4 and see if other numbers are there or not. We cannot do that. We have to make sure that if you are starting from 4, we at least have 5 or 6 or something like that. You get the idea, like 7 and 10, whatever. We have to make sure that we have at least 3 numbers including the 4 which we can use to form a new subsequence, because the second condition of the question was that every subsequence must be of length 3 or more, right? So initially we have to determine, or we have to make sure that at least 3 numbers are there including this current number that we are standing on to form a new subsequence. So we have to make sure of that, right? So this is for the second condition. And first condition will be, how will we ensure the first condition, like how will we check for the first condition, right? You might think that we can store, let's say, a number of subsequences, and let's say this is ending in 3, and let's copy this. This is ending in, let's say, 6, and this is ending in, let's say, 3 again, right? So as I said, I was standing here, right? I was standing in this index with the value 4, right? So if I'm in I have the value 4, I'm seeing the value 4, and I know that these are the only subsequences that I have till now, and out of these 3 subsequences, I know that the first one and the last one, the first or third one, ends in 3. So the obviously I know the next number here will be a 4, right? The next number to include in the subsequence would be 4. Similarly here, right? And not in this one, because we cannot include 4 now. Okay, so that means we need to keep track of all the subsequences, but that is not possible. That will be very memory consuming, if you would like, right? So that's not possible. How would we tackle this issue? We will keep a map. We will keep a map of all the numbers, right? So let's create that. We'll create a map like this, right? And we'll say the first number is 1, right? It will be 0, then 2, 0, and dot dot dot, and we'll say 4 would be, let's say, 2. Why? This map is not for counting how many numbers are there, because then obviously 1 would not be 0, 1 would be 1, 2 would be 1, right? Why 4 is 2 and rest are 0? Because we have reached this particular index. That means we have used up all these numbers, right? So we are basically saying we do not need any more of these numbers. We have already used them. But 4, since we are reaching now, and we are seeing that two of the subsequences need 4. Hence the value of 4 in the map will be 2. We'll name this map as need, right? We are saying that um, we are saying that these are the numbers that we currently need. This will also include, let's say, a 7 would be 1. Why? Because this particular index needs a 7. So we'll, instead of keeping track of all the subsequences, which will be very memory consuming, we are just keeping track of numbers that we want next for each of the subsequences. For this subsequence we want a 4, hence it will be 1, and also for this we want a 4, so 4 value will be 2. That 4 is needed in 2 of the subsequences. right? 7 is 1 because 7 is needed in one of the subsequences. So instead of keeping track of all the subsequences, we are keeping track of the numbers that we need for each particular subsequence. And as such, we'll check for every particular index if that number is needed here or not, according to this condition, right? If that number is needed for any of the existing subsequence or not. If it is needed, we'll use it and we'll reduce the value. We will reduce the value, right? So this was the logic for solving this question, right? Let's do a dry run very quickly and we'll get to the code, because code will make this question more clearer. Even if I try to explain everything, the code will make it more clearer. So let's say we are in 1, right? And okay, I forgot one more thing. This needs array will keep track of all the numbers that we need for the for all the available subsequences, right? We also need another subsequence called frequency that will keep track of all the numbers that are currently available, right? We also need to have a map for that. So I'll just write this one pretty quickly. Frequency equal to this, and here we will say 1 is 1, then 2 is 1, 3 is 2, 4 is 2, and 5 is 2, right? I'll remove this. This is the frequency map and this is the need map. Initially need will every need will be 0, so I'll not write anything here. I'll just delete everything. Let's assume that need is empty for the initial part. Okay, in the beginning of the question we'll check for the pre-existing subsequence condition first. Okay, we'll not try to start a new subsequence for every number, right? We will try to see if a number can be a part of a pre-existing subsequence or not. So let's so the first index is 0 and the value of I is value of that index is 1, right? We will check if 1 is needed anywhere, right? Is 1 needed in any of the subsequences? No. If 1 is not needed in any of the subsequence, that means that we are to start a new subsequence using 1. For that we have to check if 2 is available and 3 is available, and we'll check that in the frequency array that 1 is definitely available, but is 2 and 3 available? And it is available. That means we will use 2 and use 3, and we'll of course use 1. So the new values would be 0, then 0, and then 1, right? Okay, so we have created a new subsequence 1 2 3 starting with 1. Done. We'll move on to 2. We will check if 2 is available or not. For every number we'll check if it is available or not. If it is not available, that means we have used it up already and we can move on because we have used it, right? We can just carry on. So we'll check if 2 is 2 available. We'll see that 2 has a value of 0 in frequency. That means 2 is already used up. We cannot use it anymore. We move forward. We move to 3, right? Actually, I forgot one step. When we created the subsequence, we created the subsequence of 1 2 3, right? So that means the next number that subsequence will need, we need to keep track of that. So here we will write 4, we will write 4 1. In one of the subsequences we need 4, which is this one, right? So I forgot that step. Okay, then we move on. Then we reach 3. We'll check, is 3 needed in any of the pre-existing subsequences? It is not. As you can see, there is no 3, right? We do not need 3. That means we are to start a new subsequence, but for that we'll have to check if 4 and 5 are available, the next two numbers 3 4 and 5. So we'll check it. and yes, they are available, so we'll reduce them and we'll write here 1 and 1, right? 2 becomes 1, 4 becomes 1, and 5 becomes 1, right? So I've used that up. Okay, so this subsequence 3 4 5, what do we need for this subsequence? We need a 6. The next number we need is 6, right? So we'll say 6 1, done. We move on to 3. We reduce 3 also, sorry, because we used up 3 here, right? So we reduce 3 and it becomes 0, right? Now we move through I here. We check if 3 is available. 3 is not available. We move forward. If we move forward, we reach here 4. We check 4 is available. Yes. Then we check if 4 is needed. Yes, 4 is needed. We use this up. Good. We have added 4 to a pre-existing subsequence. We move forward. Is 4 needed? Sorry, I forgot to. This will become 0 because we used here, right? It becomes 0. 4 is not needed. We move forward to 5. This would be 5, right? Not 6. Yeah. We move forward to 5. Is 5 yeah, is 5 does 5 exist? Like we can use 5 or not? We can. Then we check, is 5 needed? Yes, it is. We use it up and we move forward to this. Is 5 needed? No, it's not needed actually. It becomes 0. And we go out of index and we return true because we never returned false. If during this whole loop, if we would have returned false, the answer would have been of course false. If we do not return false, at the end of the loop we'll return true. Let's just get coding. This will be very clear there. Okay, so as I mentioned, we'll need two maps, so let's create them. Frequency map of int to int, then need map of int to int. Now we'll set the maps first. Num range nums, frequency of num plus plus, for every number will increase its frequency, right? And initially every number will be needed. No, it will not be needed. So need of num for every number initially will be 0. Then we start a loop for every number in nums, right? We will initially check if it is available to use or not, whether to include it in a existing subsequence or to create a new subsequence. We'll have to first ensure that it is available, it is not used up already. So we'll check if frequency of num is equal to 0, that means it is not available. We will continue from this loop. That means for this stage we'll move on to the next number, right? Then as I said before, we'll always check that if we can add this, include this number to a pre-existing subsequence first. So that means we'll have to check if need of num, is this number required by any other subsequence or not, is greater than 0. If this is required by any other subsequence or not, if it is needed, we will use it up, and if we use it, the need of num reduces by 1, right? And when we use this number, the next number we need for the subsequence will be need of num plus 1. If we have used up num, the next number we need is num plus 1, right? So we'll increase that in the need map. Else if it is not needed, we have to start a new subsequence from this particular number. For that we have to check if the next two numbers are available or not. So we have to check if frequency of num plus 1 is greater than 0, that means it is available or not, as well as we have to check frequency of num plus 2 is also available at the same time or not. If the next two numbers are available, then we can start a new subsequence, right? Should be an else if. Okay, so if we start a new subsequence, that means we'll reduce the frequencies of these numbers. So frequency of num plus 1 minus minus frequency of num plus 2 minus minus, right? And for this particular new subsequence that we have started, what we need the next, we need num plus 3 next, right? So we'll increase the need for that. Else, as I said, if both the conditions are not met, like we do not need a particular number and we cannot start a new subsequence using that number, then we'll return false because we cannot solve this question. Okay, and for every step we have to reduce the frequency of that particular number because we are using that number, right, whether to include it or to start a new subsequence. If we are not, we're returning false. If we are using it, we'll reduce its frequency by 1. At the end, if we do not return false, we'll return true. Let's run this. Submit. And it is accepted. So this is a pretty good question. It's a very good question actually. The logic is very good, implementation is very good, right? If you can understand the logic and implement it, it is like a very good question. It's truly like a medium level question, right? It's not easy, it's not that tough. If you just understand the logic and can come up with this two map idea, then it's a pretty good question. So if you understood it, drop a like, subscribe and comment, and I'll see you in the next one. Thank you.